Hello, George Romanic here. We are continuing with exploring Coriolis force. Today's problem is very particular and very interesting. And a problem that you can apply to your everyday life, given that you are driving a Range Rover. You see the problem now on your screens. And the problem says you are somewhere in the Range and you make sharp turn to the right or left, doesn't matter. Why is that you are feeling centrifugal force, you bump person next to you, but you don't feel influence of Coriolis force? Can you explain that? The answer is yes, I can. So the problem says you are in your Range at 20 degrees north, radius of the curvature that you make, so if this is the center of the curvature, let's say you make this sharp turn like so, and the radius of this curvature is RC, 100 meters, and you are moving with the velocity VC, which is 70 kilometers per hour, which I believe is approximately 19 meters per second. Basically, find the ratio of the centrifugal force to the Coriolis force. Now notice that in this problem, centrifugal force is acting out. So this would be F, C, F, F. And the Coriolis force is deviating this towards the right because we are in the northern hemisphere, so this would be F Coriolis. And basically we need to find the ratio of these two forces, and as you will see at the end of this problem, this vector should really be much shorter than this vector, because Coriolis force, as you will see, is way weaker, and that's why you don't feel it in this particular situation. So let's find the ratio of these forces. I will just write CFF as for Coriolis force, and CFF for centrifugal force, and COR for Coriolis force. Now I could start like other YouTube channels, immediately showing you the scalar form of these equations, but that's not something that we will do here. Instead, what we will do, we will go how you should in principle do it, and that's start from vector equations. So centrifugal force is negative mass of this car, or mass of your body in that car, omega of the car cross omega of the car cross radius of the curvature, or radius of the car curvature around this central point, divided by Coriolis force, and Coriolis force is negative m2 omega of the earth. First point where you can make mistake, these are not the same omegas. This is omega, angular velocity of this car going in this circle, and this is angular velocity of our planet, cross velocity of the car. Okay? Now you can see that masses cancel, and we can evaluate this to be omega of the car squared radius of the car divided by 2 omega of the earth velocity of the car sine of phi, where phi is latitude. And of course here we don't have any sign of these angles, because angular velocity of this car is into the page, and so I am actually interested in the absolute value of these in intensities. That's what the problem is asking me. So I am evaluating intensities over here. Therefore, if I have any minus sign or plus sign, that doesn't matter, intensity is the same. So this is further equal. Now, omega of the car is velocity of the car squared, radius of the curvature of the car squared, time radius of the curvature divided by 2 omega of the planet Earth, velocity of the Renji, sine phi. Radius of the car and this square cancels, and this VC and this square cancels, and we get that this is equal VC, velocity of the car, 2 omega Earth. This RC will drop down and I get sine phi. And this is our solution. So this is the ratio of centrifugal force to Coriolis force. Now, in this particular case well, in any case, basically, but in our particular case, if we plug in these numbers, you will get that this is approximately 4,000. Of course, it's not exactly 4,000. If you calculate, you get 3,800 something, but let's say 4,000. That means centrifugal force is 4,000 times larger than Coriolis force. So when you are in your Renji and you make sharp turn, centrifugal force that you feel is 4,000 times Coriolis force. We can even calculate centrifugal force exerted on your body. What would that be? Centrifugal force, let's say intensity, would be mass of your body, omega c squared RC. So here I just add this mass, and that would be equal mass of your body, and again using knowing that omega is V over R, I will get here V of the car squared by R radius of the curvature. And now you can, VC is given, RC is given, and mass of your body, you should know that, and you can calculate centrifugal force. For example, in my case, mass of my body is 90 kilograms. It's really 97 kilograms. I should lose some weight. I need to lose some weight, and the primary reason is to decrease centrifugal force acting on my body when I enter Range Rover. So if you plug in this number over here, well, you will get something. I don't know now what. VC is 19, let's say that's 20, so this will be 400 divided by 100 and times 1. So it will be around 400. These are approximately same, so VC squared will be approximately, I don't know now, but approximately 400 newtons. This is the force on my body if I am in Renji doing this maneuver over here. And you see in the description of this channel that the main goal is dissemination of knowledge and improvement of learning. But really the main goal of this channel is to get enough subscribers so I can actually get Range Rover and do some proper off-roading in that car that is indeed designed for both off-roading and highways. Until next video, goodbye.